Hi everyone, my name is Sam and welcome to my Next Gen AI Guy YouTube channel. In this video, we will going to learn generative AI from the scratch. In this course, we will explore everything you need to know about a generative AI, from the basic to more advanced concept. So let's begin. First, we will see that what are the topics we will going to cover in this video. First is going to be introduction to generative AI, where I will explain that what exactly the generative AI and what are the application we can build with the help of generative AI. Next, we are having a understanding of neural network, where we will understand what exactly neural network is. Next, we will see the what is natural language processing. Next, learn about the language modeling, what exactly it is, how to use it. After that, we will learn the transformer and self-attention. The whole architecture I will going to show you with the help of animation. Next, we will move forward to a bird, means bidirectional encoder representation from the transformer. How exactly it works, how to train such kind of model, all those things we will cover in depthly. After that, we will going to see what exactly the large language model is, how to use large language model locally. Also, we will going to see that what are the open AI models we are having and how to use that in our applications. Next, we will see that what are the embedding models we have, what exactly the embedding model is, and where should we take the embedding models, how to analyze which embedding model is suitable for our particular application. Sometimes what happens, large language model hallucinate, we can solve that hallucination part, plus we will be able to build our RAG based project on our custom plus personal data. After that, we will see what exactly the image generation models we have and how does it work and how to use in our application. This is the LangChain framework which we utilize to build LLM based application. We will also going to see what are the frameworks we are having, like a Llama Index. Those two frameworks we have to build a LLM based application. I will going to explain the both framework in depthly. We will see that how to build application with the help of LangChain and Llama Index in a VS Code. After that, we will learn about the prompt engineer, what exactly the prompt engineer, how to use the prompt engineering in our application. After that, most important part is the securing our LLM, how we will going to do that. So for that, we will going to construct the security layer for our LLM application. How to do that, I will going to explain the theoretical plus practical implementation, both of it. At last, we will going to cover AI agent, what exactly the AI agent is and how to build AI agents, what are the tools and techniques we are having to build AI agents. So that was the course, and in this course I will try to cover the project as well, as so you will get a better understanding of how to create a project with the help of Python. So let's just move for the introduction to a generative AI. So here we will going to see that what exactly the generative AI is. So generative AI is a type of artificial intelligence that can create a new content such as text, images, music, or even a videos based on the pattern it has learned from the existing data. Unlike traditional AI, which mainly analyze or classify data, generative AI produce a original content by predicting what comes next in a sequence, or by transforming existing information into a new forms. For example, it can write an article, generate realistic looking images. So what are the examples we are having? You must have seen that stable diffusion for image generation means where you will write text or prompt, based on that it will going to generate image. And the next example is the chat GPT, where you will ask any query, based on that it will going to reply or generate a new content for you. The query which you have written, accordingly it will going to generate. So let's see the Gen AI application. So here we are able to see that content creation, we can create a content with the help of generative AI, like writing article, generate report, even produce a creative content like a story, poetry or script. That all we can do with the help of generative AI. We have application like stable diffusion, mid journey, where you will just write a query, based on that it will going to generate image or video. We have several models like text to image, image to image, plus text to videos as well as, or image to videos. So image and video generated is a application of a generative AI. Next, we have a virtual assistant and chatbot. Whenever you visit to a particular website, over there you will see the small pop-up in their website that it will going to ask you how can I help you. So whatever query you are having, it will going to reply accordingly. So we can build a virtual assistant and chatbot with the help of generative AI. And last one is a healthcare, like generating a synthetic data for research purpose. That also you can do with the help of Gen AI. Now we will understand the what exactly the neural network is. So, what is neural network? Neural networks, also known as a artificial neural network, are a subset of a machine learning. Their name and structure are inspired by the human brain, mimicking the way that biological neurons signal to the one another. Main objective of a neural network is to mimic the how our brain works, the way our brain transforms signals from one neurons to other. Same things neural networks try to mimic. Neural networks are composed of interconnected nodes or neurons that are organized in a layers. As we are able to see over here that we have a three layers: input layer, hidden layer and output layer. So input layer means whatever the columns you are having, that input will be fed as an input, and the hidden layers will going to process that input data. Each neurons gets some input, does some calculation and then pass the result to the next neuron. The output layer will going to predict, like identifying a cat in a picture or predicting a word in a sentence. So how does the learning happens? Just like we learn from the experience, neural networks learn from the data. They look at lots of example and figure out the patterns between it. For example, if you show a neural network many pictures of cat, it will learn to recognize what cat looks like. It will going to do it by calculating the loss function between predicted and actual data. So activation functions are used in an artificial neural network to introduce non-linearity into the output of a neuron. Without activation function, a neural network would simply be a linear regression model, which is limited in its ability to represent a complex pattern in the data. So the main objective of the activation function is to introduce the non-linearity in the output of a neuron. So how learning and training happens, for that two main term is there: back propagation and gradient descent. So back propagation is the algorithm that helps neural networks to learn by adjusting its weights and biases. It calculates how much the network prediction different from the actual result and then updates the network to reduce this error. So as we can see that in initial anything it will going to predict, and it will compare itself from the actual output, and based on that it will calculate the loss function. And each neurons in hidden layers which have a weight and biases, that weights and biases we will going to adjust according to loss we have calculated from the predicted and actual data. So how does gradient descent work? Main objective of the gradient descent is to find out the global minima. Global minima means where the loss is equal to zero or nearest to zero. For example, if any weights you have taken, based on that it will going to check the loss by calculating loss function from the predicted and actual data. This will going to find out the best weights where the loss is equal to zero or nearest to zero. So these things will allows us to adjust our weights in the neurons which is present in our hidden layer. Next we are having a natural language processing. Natural language processing focuses on the interaction between computers and human language. As we all are aware of that the computer does not understand human language, so natural language processing allows the computers to give the ability to learn the human language. Based on the NLP, the computers understand language, and based the pattern it has learned during the training, accordingly it will going to generate. So what are the application of NLP? Like we can build a chat bots and a virtual assistant, translation service like English to French or French to English. So we will be able to convert text from one language to another language. We can do the sentiment analysis as well. As so one of the best example which I have also uploaded a video on it. In that project what I did, I have converted the speech to text, and that text I perform the sentiment analysis. Sentiment analysis will allows us to find out the tone of that whole text, means was it negative or positive or neutral. That tone we will be able to find out with the help of sentiment analysis. Next one is a speech recognition, that also you can do with the help of NLP. The sentiment analysis and speech recognition project I have already built. If you wanted to check it out, you can go to my YouTube channel, and over there you will see I have explained the whole theoretical plus implementation in a VS Code. I have also shared the code link in the description. So next we are having a word embedding. As I have told you that computer does not understand the text, it understands the numerical representation of a text. So word embeddings allows us to convert that text into a vectors format, which is numerical representation of a text. So next we will cover the language modeling, what exactly the language modeling is and what are the techniques we can apply to build a language modeling. Language modeling is a specific task within an NLP. It involves creating a model that can predict the next word in a sentence based on the context of previous word. These are trained on a large dataset. For example, they are used in a text generation, autocomplete features, and machine translation. For example, whenever you are writing an email, over there you get a suggestion of a next word, what you should write. That we can do with the help of language modeling. So let's see first what are the techniques we are having. So we have a four general techniques. We will move to the transformer later. First we will going to cover this n-grams model, what exactly it is. So next one is a recurrent neural network. After that we will learn about long short term memory and gated recurrent unit. So first of all, what exactly the n-grams? So n-gram basically helps us capture the contextual information and semantics meaning within a sequence of words by providing a more understanding of a particular language. In language modeling tasks, n-grams contribute to building more accurate and context-aware models, enhancing the performance of application. We can do like next word prediction or suggestion and speech recognition also. So we have a four way to do that, like unigram, bigram, and trigram, n-grams. So what exactly it is? The unigram means in a whole sentence each word will be considered and each word will be used to train the model and each word will going to predict. In case of bigram, rather than using a one word, we will going to use two words at a time. So in unigram, as we can see over here, that from this sentence single word has been captured, like I love NLP. So this is the way to do unigram. In case of bigram, we will split the sentence into a two words, like I love and love NLP. Same way we will going to do the trigram and n-grams. So this is all about n-grams. Main objective is to capture the contextual information and semantic within sequence of words. Next we are having a recurrent neural network. So what exactly the recurrent neural network is? It's a type of artificial neural network. It is designed to process a sequential data like a time series, text, or speech data. So we know that the text we are feeding over here is a sequential data. It will going to learn the pattern in that sequential data. Based on that, it will going to predict the next word. So as we can see over here, that RNN have a connection that forms a loop. So whenever you feed a particular input, based on that it will going to process and it will produce. That output will be multiplied by the weights, plus it will be added to the next word, and then it will be fed for a next prediction. This is the hidden layer. As we have seen that in a neural network we have input and hidden layer, then output layer. So we will feed the input and it will going to process. Hidden layer is like a memory that accumulates information from the sequence as it progress. So whenever you feed input, that hidden layer will going to process and then it will going to produce the output. That output will be multiplied by the weights and it will be fed with this next input, and same loop will be going to over and over again till it achieve the accuracy. So what are the key components we are having in this RNN? So main thing is that the loop, it will going to persist again and again till the loss function is decreased. Means whenever you will feed the input, it will process, then it will produce the output. That output will be fed with the next input. This is the main feature of the RNN. And the one thing is the hidden state. Hidden state represents the network's internal memory. The hidden state is updated based on the current input and the previous hidden state. So two limitations we are having in case of RNN. One is a vanishing gradient problem and exploding gradient problem. It happens when dealing with the long sequence. These issues can make it difficult for a network to learn effectively. What exactly the vanishing gradient and what exactly the exploding gradient? In case of vanishing gradients, when your learning parameters becomes really small, that cause learn very slowly or not at all. In the gradient descent, we have seen that we have to optimize, or we have to find the global minima, so where the loss function is the 0 or nearest to 0. That was the objective of using a gradient descent. So what are the best parameters we should be using where the loss function is 0? That's the main objective of a gradient descent. So in case of exploding gradient problems, what exactly happens when your learning parameters becomes too large? So it will skip the global minima. Let me explain you with the graph so you will get a better understanding of it. How does gradient descent work smartly? That it will take a larger step during when the loss is quite large. When loss is nearest to the global minima, it will take a smallest steps. Why? Because it should not miss that global minima where the loss is 0, and we will going to find our best parameter over here. So that was the main objective of gradient descent. So in case of exploding gradients, when your learning step will be higher, so you might miss your, so for example, this is the first jump, this is the second, this is the third, we might have missed our global minimum. So in case of a vanishing gradient, these steps becomes quite small. It is not able to learn, it is not able to move further. It will going to increase our training time, which occurs in the case of RNN. Okay, next we will going to cover the long short term memory. So long short-term memory is a type of recurrent neural network architecture designed to overcome the limitation of traditional RNN, particularly the vanishing and exploding gradient, which I have explained. LSTM are well suited for processing and making prediction based on the sequence data, especially when long-term dependency are involved. In that whole paragraph or whole sentence, what should I remember and what should I forget? That's the main objective of LSTM, that it handles with the help of memory cell. So how does LSTM works? So we have a cell state, means cell state is the memory of a LSTM cell which carries relevant information across the different time step in the sequence. This state can be modified by the forget gate and input gate, allows the LSTM to remember or forget information as needed. So cell state is the memory of LSTM. It have three key components. First is the forget gate, the next is the input gate and output gate. Forward gate decide what information from the previous hidden state should be discarded or kept, means what should I remember, what should I kept. So that information was handled with the help of forget gate. So how does it work? The forget gate takes the current input and the previous hidden state and outputs a number between 0 and 1. 1 means keep this entirely and 0 means completely forget this. In case of input gate, decide which new information should be added to the cell. In case of output gate, decide what information from the cell should be output as a new hidden state. The output gate filters the cell state through a sigmoid function. Sigmoid is a mathematical function that maps the input value between 0 and 1. We have seen the forget cell, input cell and output gate. Main objective over here is to what should I remember, what should I forget. Next we are having a gated recurrent unit. This is also a type of recurrent neural network architecture like a long short term memory. This also used to handle the sequential data and solve the vanishing gradient problem. This is the simple alternative of LSTM with fewer gates and parameters, making them computationally more efficient while still being effective at capturing long-term dependency in the sequence. So the first we have seen the RNN, then the advanced version of RNN is the LSTM. Next we are having a gated recurrent unit. So as we have seen that in the case of LSTM we were having a 3 gate which allows us to control the flow of information. So in case of gated recurrent neural network, we have a two main component, which is the reset gate and update gate. So what exactly the reset gate? It controls the how much of previous hidden state should be forgotten. In case of RNN, if you feed the long paragraph, each one will going to process that and will be difficult for them to learn. Those are the problems we are trying to resolve with the help of LSTM and GRE. So reset gate controls how much the previous hidden state should be forgotten. It decides how much the past information should be ignored or passed to the next step. as we were doing with the help of forget. So this is the crucial when the networks need to reset memory, particularly when encountering a new. But in case of LSTM, we were having a forget cell, and here we are having a reset gate. And the update gate determines how much of the previous hidden state should be passed to the current hidden state. It decides the amount of old information to retain and how much new information should be added. So this update gate decide the amount of old information to retain and how much new information should be added. Now let's jump to the transformer, which is quite important one, and we will see with the help of animation also, so it will be quite easier for you to understand. So what exactly the transformer is and what is actually the self attention. So what exactly the transformer and how it is different from the RNN, LSTM or GRU. So in case of RNN, LSTM, we have seen that it will going to process the data sequential way. But in case of transformer, we can feed the data in a parallelly. A core innovation of a transformer is the self-attention mechanism. It allows the model to give the importance of a different words in the sentence related to each word. It process the entire sequence in a once, and in case of RNN and LSTM, we have to one by one, like in a sentence, this is a cow, so we have to first feed this, then we are feeding is, then we are feeding a cow. So and other things making it different from the RNN and LSTM is that it has an attention mechanism which gives attention to the particular word with respect to other words which is present in the sentence. This is the architecture of a transformer. We have an encoder and decoder. Main objective of encoder is to, when you provide input, that will going to process and do the encoding, which is in a vector format. Vector is a numerical representation of text which will capture the semantic meaning of that particular text. Same way decoder will work, means it will going to decode that from that vector to text. How does it learns, we will say. So in case of RNN, process the data sequentially. So first I have fed the, based on that it has encoded that text into a vector. Next I have fed black, again it will going to produce a vector. Then I have to feed the last word, the sentence is the black cat. So I have fed the cat and it will going to process, and again it will going to produce the vector. In case of transformer, we feed the whole word parallelly and it will going to produce the vector accordingly. So that was the major difference between the RNN and transformer. The other difference is the attention mechanism. Attention is all you need. It's a research paper. You can read it out. I will explain you that in a simple way. Input embedding, which means gives the computers the ability to learn the text. We all are aware that the computer does not understand the text. It understands the numbers. This vectors allows the computers to learn and understand this text. For example, when we are feeding this text, the king is born, we are converting words to vector. It will going to convert, means this is the vector with respect to all words in the sentence, and this vector is a numerical representation of a text. What exactly the input embedding does, it will convert the text into a vectors with the help of word to vect embedding model, which allows us to convert the text into a vector, which is numerical representation of text. For the example, we will see this Sam cat is cute. Sam's look like a cat. The cat meaning of in this sentence is different from the other sentence, so that's where the positional encoder comes in. It will going to capture the position of that word in that sentence. What is the location of that word in the whole sentence? That information will be captured by the positional encoder. So as we can see, the cat over here is having the position 2. The next we are having the cat at a position 5. So the position encoder allows us to capture the position of that word with respect to particular sentence. This is the formula they use to calculate the position encode. So first what we are doing, first we are converted the text into embedding, then we are applying the position encoding, which will capture the position of the each word with respect to other words in the sentence. Then we are combining both to the embedding of that word and the position of that word. We are creating a final vector of that text. So we have covered the both thing. This is the encoder part we were covering. So we have seen that how that input embedding model works. It will process that text and convert that text into a vectors with the help of embedding model. Next we are having a positional encoding, which we have seen that after converting the text we are encoding the position of that word with respect to other words in a sentence. Next we will see the encoder block. So in that we are having a multi-head attention and feed forward neural network. So what is the attention? Attention is the what part of sentence should we focus. So attention allows the model to weight the importance of each word in the sentence relative to other word. For example, so in case of the big red cat, this red color will be assigned more attention towards the dog, not the other words like a big or the. How does it calculates? The self attention mechanism calculates three vectors for each word in the sequence. First one will be query, the next one is a key, and the last one is a value. What exactly the query? Query is what this word is looking for in other words. That is a query. And what is a key? What other words offers that this word might be interested in. What is value? The actual information from the other words. So those were the three vectors it calculates during the attention: query, key, and value. We will see that also how do we do that. So we are having a multiple head attention. Why? Because instead of calculating self attention once, multi-head attention computes it multiple times in a parallel, each time with a different learned linear projection of a queries, keys, and value. Why we do that? Each attention head captured different relations between word. One head might focus on a short range dependency like adjacent word, while other might capture long range dependency like a subject and its corresponding verb further in the sentence. So after each head has computed its attention, the result are concatenated together and pass through the final linear layer. This process combines the diverse insights from each head into a unfilled representation that carries richer information than any single attention mechanism could. So that was the main objective of using multi-head attention. So multi-head attention will going to compute parallelly. Each attention had the query, key, and value vector. The query is what this word is looking for in other words. Key is what other words offers that this word might be interested in. The value is the actual information from other words. So why we are using multi-head? Because it captures diverse relationship and enhance the model. Multiple head allows the model to capture different meaning of the words in a different context, making the overall model more expressive and powerful. So we have covered the input embedding, positional, and we have covered the multi-head. Next we are going to do the normalization, and after that we will use the feed forward network. So first we will feed the text, it will going to do embedding, then we are doing the positional encoding, which will capture position of the word with respect to other words in a sentence. After that we are using multi-head attention to capture diverse relationship between the words. Next we are having a feed forward neural network. After that vectors will be passed to the feed forward neural network. For example, this is the text we were having, this one having the combination of positional multi-head attention. After that the vectors we are having that we will pass in the feed forward neural network to process it. This is the input layer and this is the hidden layer. It will going to process, assign the weights and biases, apply the activation function, then it will going to produce the output which is given over here. So we have covered the encoder part from the input to the final output. So we have fed the big red dog, and based on that it has produced the vector. After going through input embedding, positional encoding, multi-head attention, feed forward neural network, this vector has been generated. So before moving to the forward, I will request you to please like and subscribe, because it will give me a motivation to create such kind of videos. Thank you in advance. I hope you are enjoying this learning. So we have completed the encoding part. Now we will move to the decoder part. How does exactly it works? Imagine that you wanted to convert this English to French or German, any language you wanted to convert in it. The output sentence in the target language is fed into the decoder part. Means here we are feeding the French language. This sentence is first converted into a vectors using an embedding processing similar to how the encoder processed in the input sentence. We have seen in case of encoder, a positional vector is added to these embeddings to capture the order and context of words. After doing the embedding and positional encoding, we will concatenate the vectors and then we will pass that vector to a masked multi-head attention. The first attention block is the decoder, is called masked self-attention block. This block generates the attention vectors for each word in the output sentence. These vectors capture how much each word in the sentence relate to every other words in the same sentence. The masked part means that model is only allowed to consider the current and previous word in the sentence while predicting the next word. This mask prevents the model from cheating by looking ahead the words it is supposed to predict. After that, we are going to do the cross attention. What exactly the cross attention is? The decoder also attends to the encoded input from the encoder. Means we will get the data from the encoder, which we have seen that. So here we have fed the text. Based on that, it has generated the vectors. That vectors will be fed over here. So the decoder also attends to the encoder input from the encoder. These steps helps the decoder understand the context or source information to generate contextually relevant output. So after doing the masked multi-head attention and multi-head attention between the encoder and decoder output, then we will move forward to a feed forward network. After the attention mechanism, the output is passed through a feed forward neural network. So we have already understand that how the feed forward neural network works. The output from the feed forward network is passed through the linear, then will be passed for a softmax layer, which converts the raw prediction into a probability of each possible tokens. The token with the highest probability is selected as a next word in the sentence. That's how our encoder and decoder work in the transformer. Now we will move forward to a BERT. So BERT is a bidirectional encoder representation from transformer. In the transformer, we have seen that we had a two part, the encoder block and the decoder block. If you will combine the multiple encoders, that we call it as a BERT, and if you will combine the decoder part, that will be architecture of GPT. So in this bidirectional encoder representation from transformer, we are combining the multiple encoder from the transformer. That was the way to create a BERT. So application of the BERT is a question and answering. You can ask a question, based on the learning it will going to generate the answer. How exactly it does, I will going to explain you. We can do the sentiment analysis also, like finding out the sentiment of a particular text. Is it neutral or negative or positive? That sentiment analysis we can do with the help of BERT algorithm. We can also perform a text classification and name entity recognition. So these are the application we can build with the help of BERT. Building this application requires a language understanding. So how we are going to train the BERT algorithm? So to do that, we have two techniques to train the BERT. First one is the pre-train BERT to understand language. Then we will going to fine tune the BERT to learn the specific task. First we will see that pre-training of BERT to understand language model. Pre-training the BERT to understand language. First one is a masked language modeling, and next one we are having a next sentence prediction. Both way we have to perform on the BERT to understand this language. What exactly the masked language modeling is? We will going to mask some words in that sentence. So model will going to try to predict those words. What should be present over here? What should be present over here? It will going to try to predict. When it will going to predict, we will going to calculate the loss function with the help of actual versus predicted. The model will going to run till it will achieve accuracy or the loss will be nearest to 0 or equal to 0. So after doing that, next one is a next sentence prediction. What exactly it is? Means we have a two sentence in the paragraph. Sam is a YouTuber. Next he explains Gen AI. So it will going to tell that does this second sentence follows the first sentence or not. So that was the motive do next sentence prediction. Over here it will going to classify, yes, sentence B follows sentence A. So after doing these two ways, it will going to learn the language. Next we will see that how to fine tune the BERT. To fine tune on a specific task like a text classification, sentiment analysis, we have to fine tune the question answer. Means the data set will be, one is a question, other will be answer. So on that data set it will going to train. So this is the question and the passage, both will be feeded, and this is the extra layers will be added on that BERT algorithm. This is the algorithm which only understands the language, and the extra layer we have passed, these layers will be learned from scratch on that specific task. We are going to fine tune only the previous layer, means the language understanding layers we will going to fine tune, and this layer we will going to train from the scratch. So that's how the fine tuning of BERT work. Now we will see the variants of BERT. We have around 5 variants of a BERT algorithm. First is the robot. In this robot model, which is the version of a BERT model, in which only things is different is that we are using a large training data set, and the training duration is going to be quite longer as compared to the BERT model. And also we are doing the dynamic masking rather than static masking. So in the digital BERT, we have a 40% fewer parameters than BERT, and speed runs 60% faster than the BERT model. So performance retain around 97%. So this digital BERT is a quite smaller, faster and cheaper version of the BERT. That's the only difference between the BERT and the digital BERT. Next we are having Albert. So in case of Albert, we are sharing the parameters across the layer to reduce the model size, and we are doing the factorized embedding, means splitting the embedding matrix into a smaller matrices to improve efficiency. And here we have a tiny BERT, which is also a version of a BERT. It is the compressed version of that BERT, applies both knowledge distillation and the data augmentation techniques. The size of this model is quite smaller and it's really faster than BERT. At last we are having a span BERT. So span BERT is a variant of BERT. While BERT focus on understanding the meaning of individual word in a sentence by predicting masked word, span BERT goes step further. So span in the span BERT refers to a continuous sequence of word. Over there it will going to mask the not only one word, it can be 2 or more words together. So that's way it will going to capture the more meaning of that sentence. So that's why span BERT is better than BERT. So that was the difference. In BERT only we masked one word. In the case of span BERT we masked multiple words together. Next we will move for a large language model. What exactly is the large language model? Large language model is just a language model. Why we call it as a large language model? Because it has been trained on a huge amount of data. You must have used the Chat GPT or Gemini or Google Bard. You can find out the accuracy of those models are really good because it has been trained on a huge amount of data. In the large language model, we used it for answering question and summarizing text, to translate language and generating a creative content. So we have a different kind of model. We have a Chat GPT 3.5 model, which was trained on the decoder block. Reinforcement learning also has been included in the case of GPT. So capabilities of GPT 3.5 is it can translate the text from one language to another language. So it will be able to answer based on the query you have written. It can generate concise summaries of a longer text such as documents and reports. It also generates the content for a wide range of use cases and writing projects such as email and code. Next we are having a ChatGPT 4. We all must have heard about that OpenAI released the ChatGPT 4.0 mini, which is quite fast as well as affordable as compared to GPT 3.5 Turbo. If you're looking for a subscription, then you should choose that one over the ChatGPT 3.5 because it's quite fast as well as it is quite cheaper as compared to the GPT 3.5. So next we are having a Llamas model. Meta has launched several large language model. One of them is a Llama model, means language model from a Meta AI. It can be used for a different task. It is based on transformer architecture, which we have seen, specifically the decoder part. Similar to model like ChatGPT 3.5, I will also going to show you how to run the model locally. Then we are having a Mistral open source large language model. It's a French company. It also provide the large language model. Next, both we are going to see the large language model using locally, and also we will see that how to get a free API key for a large language model. So the first way is Ollama. Ollama is a platform that specializes in providing access to a large language model locally. So I will show you how to do that. To do that, first you have to install Ollama application in your operating system. So first go to the window and type over here ollama.com, and here we are getting this web page, and over there you just need to click on that download button and you will get a 3 option to download. So if your operating system is Windows or Mac, so you have to download this application. If you are having a Linux operating system, then you just need to type this command in your terminal. After doing that, it will going to install that Ollama locally. After doing that, you just need to write the in your terminal Ollama pull the particular model name. How you can get the model's name? Just click on this models. Here the Ollama platform provides several models. Any models you want, you just copy the name of the model and write in your terminal Ollama pull that model's name, and it will going to load that model locally. Ollama 3.1 is recently launched and it's quite free to use. After that, this is the GPT for all. This also provides the large language model accessible in your desktop or laptops without any API key. So you will be able to run the large language model locally with the help of GPT for all. Same way, you can go to the website and download this GPT for all and run the large language model locally in your PC. After that, we are having a Grok. In case you want to access the large language model through API key, which is free of course, so that also you can do with the help of Grok. You just need to open this grok.com and over there just log in and go to the API key section and create a new API key, and that API key you can paste into the .env file. You will be able to access this any large language model through the API key, which is quite fast. The response time of this all large language model is quite fast because the working procedure of Grok is a LPU. We know that the CPU, GPU, but LPU is a language processing unit. Language processing is used by the Grok, so that's why it's quite fast as compared to the others. So I will going to show you in the project also that how to use this Grok AI model and how to access this model during the project. Next, we are having embedding models. What exactly the embedding model is? So embedding model allows us to convert the text into a vectors, which is a numerical representation of text. So you are going to feed the text, the embedding model will convert this into a vectors, which is a numerical representation of text. So in the embedding model, we have a dimension. What exactly the dimension is? So dimension is like a feature. For example, you are taking my name, Sam. So Sam is a human being, his gender is male. Those all are the features. So those two features you will consider it as a dimension. So next we are having a token. So tokens are the basically unit of text that model process. So token can be word, character, or even a phrases depending on how the text is tokenized. Now we will see that how to access those embedding model. So those embedding models you can access from the Hugging Face. Hugging Face is a platform which will provide several things like a data set, large language model, text to image model, image to image model, and embedding model also. It provides you the space as well as to upload your model over there, and you can run your model also. So first we will see that how to use the embedding model from the Hugging Face. Let's open the Hugging Face. I will show you how to do that. So go to your web browser, type the huggingface.com, and over there you will get, this is the web page you are getting, Hugging Face home page. In the left hand side you will get your profile, inbox settings, so many things, and on the upper side you are able to have a models, dataset, spaces, post, docs, solution, and pricing. On the model section you will be able to access the all models like a large language model, text to image models, or embedding model. Here we are having a data set. You can access the several data set from there. This is the space part where upload your large language model and you can run the project in this Hugging Face space. First I will going to show you that how to create an API key. To do that you can directly go to the setting from here, or you can click on this icon and just go to the setting, and then you can click on this access token. Just click on the create new token. Here you just need to type the token name, the what purpose you are wanted to, if you wanted to for a read or write, then if you wanted for a both thing, then just click on this read and write, and then just create the token. So this will going to create the Hugging Face token for you. So first we will see the models over here. Main thing, we have come here for a embedding model, but I will going to show you the large language model as well as plus text to image plus image to text model. After clicking on the models, we are able to see that the task over here. Here we have a multi-model. like text to text plus image to text also model we are having. And here we have a related to the computer vision task. That's the separate part of the computer vision. I will try to cover this one in future. So here we are having a natural language processing task like text classification, token classification. If you any task you wanted to perform like a summarization, if you will click on it, here you will get the models related to the particular task. And here we are having audio, like if you wanted to convert from text to speech, that also you can do. Audio to text, text to audio, all those things you will be able to do with the help of this task. Here we are having a tabular, reinforcement learning, and other one. Now we just need a embedding model. So to have that, first we will go to the embedding leaderboard. So this is the leaderboard of all embedding models. Over here you can find out the all the details whatever task you are doing. According to your task you can select your embedding models. On rank 1 we are able to see that BGE ENICL model, which have a 7111 million parameters and its size is around 26 GB. So it has a 4096 dimension, means the feature. The max tokens limit is 32,000. Only these much of tokens you will be able to provide. So based on your needs or your problem you are trying to solve, you can choose any model. For example, if you're looking for a BGE one, just click on it and it will going to take you to the Hugging Face where the model it is given. The code is also given over here. You just have to git clone this one. So based on this code you will be able to encode your text to vectors. Based on your requirement you can choose your embedding model from there. So we have seen the Hugging Face, we have seen the how to access the embedding model from the Hugging Face. So you can get from the sentence transformer library also. You just need to type the pip install new sentence transformer and you can give the models which are present in this sentence transformer, and this will going to load the that particular embedding model, and you will be able to convert your text to the vectors with the help of those embedding models. Next we have a Ollama embedding model. I have shown you that how to download the Ollama locally. In that models you will also going to find the embedding model, and you can load that embedding model from that Ollama and run the embedding model locally. So next is the RAG. RAG is a retrieval augmented generation. Sometimes what happens that model hallucinate, means large language model hallucinate when it does not have that knowledge with respect to particular query, or it does not know about your private data or your custom data or latest data. So in such scenarios we can use a RAG based application to provide the custom data, private data, or your current data to the large language model. So training the large language model is costly. There are three ways. Either you can train from scratch or you can fine tune the model. Those two ways are quite expensive and it requires higher computational plus long time to train such models. So we have a RAG also which provides the custom data to the large language model as a context. So based on that context it will going to generate the output. So RAG stand for a retrieval augmented generation. This is the architecture of a RAG. How exactly it works, let's see. First we are having a text. So that text can be in any format like PDF, docs, whatever data you are having locally or personally, that must be in a PDF or doc format. That doc format will be passed. Chunking allows us to convert the whole documents in a manageable chunk. So after doing the chunks, means splitting the document in a smaller chunk, we will going to do the embedding. Embedding models is used to convert those text which is in a chunk. That chunk text will be converted into a vectors, which is a numerical representation of text. After that we will going to store that vectors, means that numerical representation of text, into the vector database. I will going to show you in the Python code as well as that how to do that. First understand the theoretical part, how exactly it works. So first we loaded our documents from the particular directory. After that we have split that document in a manageable chunks, and then we have applied the embedding models to convert those text into a numerical representation. Then those vectors we are storing into the vector data. So whenever you will ask any query, so that query will be converted into the vectors with the help of embedding model. After that it will going to do the similarity search between your user query and the data which is stored into the vector database. It will going to do the similarity search and then going to extract the relevant data with respect to that query. So that retrieved data will be passed to the large language model. That large language model will going to have the both thing, the user query and the retrieved data. Based on that, it will going to generate the final output. So that was the way to build a retrievable augmented generation. That's how it whole architectures works. So let's just move to the next part. Image generation model. I have shown you in the Hugging Face that we have a text to image model as well as. So how does that image generative models works? In image generative models, we will going to see that what are the ways to create a image generative model, how does exactly works, how to train the such kind of models. So first way is a GAN. So GAN is a generative adversarial network. It's a deep learning model used for generating new or synthetic images that resemble the real image. So in the GAN, there are two main components. First is a generator, the second one is a discriminator. So generator, what exactly does, the generator's job is to create a new images from a random noise. These images start off as a random, but as a training progress, the generator learns to create images that increasingly resemble the real images. The generator takes in random input, often a vector random numbers, and applies a series of transformation to produce an image. This image is passed to the discriminator, and based on the discriminator has learned how does real images look like, it will going to classify that generated image is real or fake. So based on that, the loss function will be calculated and that feedback will be fed to the generator. Based on the feedback, it will going to improve and it will going to generate the image, and that generated images will be fed to discriminator and it will again going to classify real or fake. So that process will going to happen again and again. So this is like a rat and cat competition. So both is trying to compete each other. So when it will going to stop, so when the discriminator is no longer is able to classify that the generator model is fake and it is able to generate the good quality of image which is directly going to resemble the real image. Next we will see the variational encoder. So variation autoencoders is a type of generative model in a machine learning that is used to create a new data samples that resemble the original data. We are popular for generating image but can also be applied to other types of data such as text to text or audio. So in this one we have input, encoder, latent code, decoder and reconstructed data. The encoder is responsible for compressing the input data, which is an image, into a lower dimensional space known as a latent space. Instead of encoding the data into a single point, VAE encodes it into a distribution like a Gaussian distribution, which also we known as a normal distribution. Encoder output two things for each input, the mean and the variance of a latent variable. This allows the model to sample different points from the latent space, which is crucial for generating a new data. So why do we need a latent space? The latent space is a lower dimension space that represents the compressed version of input data. Each point in the space corresponded to a potential version of input data. The key feature of VAE is that they don't just compress the data into a single point but instead into a distribution. During training and generation, the model samples point from this distribution to create a variation of the input data. Next we are having a decoder part. So the purpose of decoders, the decoder takes point from the latent space, which is a sample from the distribution, and reconstruct it back into the original data space. By sampling different points from the latent space, the decoder can generate new data samples that are similar to the training data but not exact copies. So in that one we get a loss function also. How we are doing that? Loss measures how well the decoder output matches the original input data. The goal is to make the reconstructed data as close as possible to the original data. So we have seen that encoder, latent space and decoder part. How does it actually work? In simple words, you provide an input image, it will going to encode and it will going to plot the distribution into the latent space. From that latent space, it will going to decoder will going to generate the output. So it should be not the exact copies, but it should be similar to the original input data. Next we are having a diffusion model. What exactly the diffusion model is? So In simple terms, it will going to first it will going to add the noise in that image, and then we will going to do the denoising. So that step it will going to learn. So how does exactly it works, we will see. So diffusion model operates through two main processes. First is the forward diffusion, and the next is the reverse diffusion. What exactly it is, let's see. Forward diffusion. In the forward diffusion, we will going to add the noise one by one till the complete noise is added to the images. And in case of reverse diffusion, we will going to reverse that. We will going to do the denoise one by one, and those pattern it will going to learn that how it has been generated from that noise to that images. So that pattern it has been learned, and in the training parameters it will be saved, that weights and biases will be saved, that how to create that boy image from that noise image. So that's how the diffusion models work. Two main feature were the forward diffusion and the reverse diffusion. So before covering this LangChain framework, which allows us to build a LLM based application, I just wanted to show you the most two popular platform where you can have large language model. One is OpenAI and the second one is a Gemini. So both we will going to see that how to get the large language model, text to text model plus text to image model plus image to image model from the OpenAI as well as the Gemini. So first let's see the OpenAI. This is the OpenAI website. Just click on the link which is given in the description, or you can type the openai.com and go to the docs overview section, and over there you will get the documentation, what are the models we have and how to access those models. So this is the OpenAI developer platform where you can get the OpenAI model. Recently we have seen that the OpenAI have launched the GPT-4o mini, which is quite faster, affordable plus intelligent also. So how to build the application on such models, all the models that we are having. So we will go to the quick start, and here if you are coming to the first time, you just need to sign up and buy the LLM model according to your needs. I will suggest you to choose the LLM ChatGPT 4.0 mini, which is quite fast plus cheaper than the ChatGPT 3.5 turbo. After logging successfully in the OpenAI, just create a API key, and that API key you can export. If you're using a Mac OS or Linux, you can write this one, or if you're using Windows, then you can run this one in your PowerShell. So here we are having how to request those APIs. From that API you will going to access the LLM model. So we will see in the case of Python, first we have to install that packages. To install that, we just need to type the pip install OpenAI in our terminal. It will going to install the OpenAI package in our environment, which can be a Conda or virtual environment. So we have to generate the text, and that to generate the image, create a vector embedding. Each one of code is given below. So what exactly we are doing, we are importing OpenAI. After that we are just initiating that client, and in that client we are passing the model name, and this is the message, or you can say instruction. As a role we have given the system, this is the instruction we are giving to the LLM. You are a helpful assistant. So that is the job you're defining, or role you're defining to the LLM model. LLM model will going to work as a helpful assistant. So this is the query you are passing as a role of user. Based on that, it will going to generate the output. So that output will be generated with the help of this large language model, and you're printing that output over here. So in case if you wanted to go through this all things, you can do that also. If you are looking for a text generation, then you can use this model. If you wanted to vision models, means image to text model also, where you will provide the images and it will going to provide the description. It will going to generate the description based on the image you have provided. So text generation, vision generation, or function calling is also there. In case of AI agents, which we'll also going to cover in this video, so over there I will explain you what exactly the function calling is. That function calling power we are giving to the large language model, so that we can do structure output. Structure output parser allows us to parse the data of LLM into particular format. For example, a JSON schema. That schema you can define over here. This is the pedantic model. We have imported the base model from the pedantic. What exactly the pedantic? And what exactly the base model? This allows us to create a model, means you are giving the output of the LM model what it should be and what its format is going to be. Means here we have defined the base model, which includes the name and the data type of that name variable. And here we have defined the date, the participants. So that base model you will define, and that base model you will pass to the LM model. Based on that, the LM is going to generate the output. So that feature is also available in this OpenAI. So that was all for OpenAI. Now let's just move to the Gemini. It was developed by Google. So how to access this and how to do that, you can just click on this run on a Google Colab, and it will going to open the notebook in a Google Colab. This is the tutorial. I will explain you how to install it. So first, to install it, just you need to type this pip install -q-u google generative AI. After that, you just need to create API key, which you create from here, and that API key you need to pass, and you can export that API key, or you can paste into the .env file with the help of python.env. You can import that. I will going to show you in the code also that how to do that. Means you are saving that API key into the .env file, and with the help of python.env packages you will load that API key whenever you need. So here we have initialized our model. First we are importing the Google.generative AI as a Gen AI. Next we are importing the operating system. In the Gen AI configuration we are passing the API key, which we have imported from the operating system .environment, and here we have passed the API key. Next we will define our model, which model we want, Gemini 1.5 Flash, or we can define the Gemini 1.5 Pro, which is recently launched. Then that one is a multi-model which can process the image plus text both. So to generate that, you just need to initiate that model.generate content, and here you can write your query whatever you want. For example purpose, it is written that write a story about AI and magic. So based on that, it will going to generate, and here we are printing the response. So that was the way to develop. In case if you wanted to build a RAG based application with Gemini 1.5 Pro, which is recently launched, which support retrieval augmented generation also. So over there, first you have to load the document from the directory, and that directory you can load from that genai.load documents, and over there you need to pass your documents. It will going to load the documents and save into the cloud, and you just need to write your content over here, model.generate content, and it will going to fetch out the data with respect to query from the saved documents. We are having several things, so text generation, vision, audio, so many things you will be able to do. As we have seen the OpenAI, the same thing you also can do over here. So those were the two platforms, OpenAI and Gemini AI. So hope you understand that. Now we will move forward for LangChain framework. So LangChain framework allows us to build LM based application. This framework consists of several open source library. First one is the LangChain core. Next we are having a LangChain community. After that we are having a LangChain. From there we can import the chain, agent, or retrieval strategies. LangGraph we are also having, LangServe, then last one is a Langsmith. So main three things we need is LangChain core, LangChain community, and LangChain. So these open source library we will use, and we will going to build the application on that. Sure, let's see how to build a project with the help of LangChain. So this is my GitHub repository, NextGen AI guy. If you wanted to have this code, that GitHub repository link I will give into the description. So first what we have to do, first we have to install these packages into the terminal, or you can write this LangChain community or sentence transformer into the requirement.txt file. Like here it is, in that requirement.txt file you can write all this packages name. In your terminal you can directly run pip install -r requirement.txt file, which will going to install the all packages which is mentioned in the requirement.txt file. After that we are importing the libraries over here. First we are importing the directory loader, which allows us to load the documents from the given directory. Next we are importing the Chroma, which is the vector database where we are storing the text data after converting into a vectors, which is numerical representation of text. That one we are storing into the Chroma database, which is open source, and you can store into locally as well. So after doing that, we are importing recursive character text splitter. This is the splitters we used it to split the whole document into a manageable chunks. This recursive character text splitters split that whole document recursively till the end. After that, we are importing retrieval QA from langchain.chain. So this is the retrieval QA chain, which allows us to combine all the components in a one chain. So after doing that, we are importing sentence transformer embedding from the langchain underscore community dot embeddings dot sentence transformer. I have already shown you that sentence transformer, we can use it to import embedding models. So that sentence transformer we are importing from the langchain community. After that, we are importing the sentence transformer embedding. Next, we are importing the Hugging Face hub from the langchain community dot llms. After that, we are using the jet grok, which I have told you that we will see that how to implement LLM model from the chat grok. So after doing it, here we have passed our directory path. Here you need to define your directory path from where you wanted to load the documents. After doing that, initiated our directory loader, which we have imported over here. So in that directory loader, we will going to pass our directory path, and this show progress will going to show you that in the terminal that how much it has loaded and how much it has left. So here we have initiated our loader dot load. It will going to load the all documents from the given directory. Next, we are splitting our documents with the help of recursive character text splitter. Here we have provided the chunk size is equal to 200 and chunk overlap is equal to 20. Means the whole documents will be split into a 200 chunk size, or you can say a 200 words, and chunk overlap is a 20. Means for example purpose, if the whole document is split into a two chunk, so first chunk's last 20 words will be present into the next chunk first 20 words. So both first chunk last 20 words and the last chunk first 20 words will be same. Here we have initiated our splitting documents, which will going to split the document recursively. After doing that, we are just loading the embedding model from the help of sentence transformer embedding model. Here we have passed the name of the embedding model. We are using all mini LM6 v2. If you are using for a production level project, please change this one from to the by looking the leaderboard in the embedding model, which I have shown you in the Hugging Face. From that leaderboard, you can find out the best model according to your need. Here we have passed the persist directory path where we wanted to store our database locally. So this Chroma vector database allows us to store that vector database locally or in your disk. Here we have initiated our writing from documents, and this one we will going to pass the document which is splitted by the recursive character splitter, and then we are passing the embedding model which we loaded over here. After doing that, we are passing the persist directory, is where we wanted to store our database. If in case if you wanted to use other database like a Face CPU, it is developed by the Facebook. It is also open source. It supports the persist directory function also. If you wanted to use a face vector database, then you can uncomment this one or comment this Chroma database, and you will be able to save the data into this face database. Next, we have a retriever function. This is the vector database which we have over here. We are using as retriever function, which allows us to retrieve the document based on the query. So we have three kind of retriever. The first one is just a simple as retriever. By default, it will going to use the MMR, means maximum marginal retriever. The next one is a similarity score threshold. Means if you are writing a query, then it will going to do the similarity search from that document. So that similarity score threshold we can provide over here. We are giving the similarity score threshold is equal to 0.5. Means if the similarity score is above the 50% between the query and the document, only those retrieved documents we need, not below the 0.5. So that also we can define over here. Here we pass the search keyword arguments k equal to 1, means how many documents you wanted to retrieve. If you wanted to retrieve more than one document, then you can change this k values from 1 to as number of documents you want to retrieve. Here we have used the large language model from the Hugging Face. Here we have passed the repo ID, which is Google/flan T5. In the Hugging Face, we have seen that in the model section, we just need to choose the whatever large language model we want, and that repo ID we can write over here, and the model keyword temperature we are providing 0.5, which range between 0 to 1, means 0 is quite less creative and 1 is more creative. And the max length of 512 means whatever the text it will going to generate, that maximum length is going to be 512. I told you that I will show you how to use the chat grok, means grok LLM model also. So we have imported this chat grok from the langchain underscore grok. We can define the any model which is available on the grok platform. So in this case, we have provided the temperature is equal to 0, model is equal to llama 3. So any models if you want, that model like Mistral or llama 3.1, that model's ID you can pass over here, and here you need to pass the API key. After doing that, we are creating a chain. So chain is allows us to combine the all components in a one single chain. So here we have used a retrievable QA chain. From that one, we are passing the tuple LLM, means large language model, the vector store retriever function, and the return source document is equal to true. That source documents also it will going to retrieve. And here we just have to pass the instruction to the LLM model, like a warning, whatever you want, instruction you want, you can give it over here. Here we are passing the question with respect to warning, plus you are a helpful AI assistant. Your job is to generate output based on the query. Here we are taking the query. When you will run this code, so this will going to ask you to write the query. So that query we will going to pass, and we will pass that query into the QA chain. So that QA chain, which is over here, will going to first retrieve the data from the vector store retriever, then it will going to pass to the large language model, and then large language model based on the query and the retrieved data, it will going to generate the final output, which will be printed over here. So that's how we build a project with the help of LangChain. So I have shown you how to build the project with the help of LangChain. Now let's just move to the next framework, which is Llama Index framework. Llama Index frameworks allows us to build a LLM based application. This is also the same as we have seen the LangChain. Some features are different from the LangChain, but overall objective is same, is to build the LLM based application. Definitely I can show you how to build the application with the help of Llama Index. So let's begin. So in this one, main objective is to, we are using a database which is a SQL database, structure query language database, where the data is stored in the table format, means rows and columns. If you have used the SQL query before, then you must aware of that whenever you wanted to retrieve the data from the SQL database, you need to write the structure query language, like a select star from a particular table. So you need to write that query. What about your client? If that client, he does not know that how to write the SQL query, but he wants any application which will allows his query should be automatically converted into a structured query language, and then it should retrieve the data, and that retrieved data will be shown to the application. So in that kind of project we're trying to build. To do that, first we are importing the create engine from the SQL Alchemy, which allows us to create an engine to connect with the SQL database. Here we are importing the SQL database from llamaindex.core. Next we are importing the text from the SQL Alchemy. After that we are importing the natural language SQL table query engine from the llamaindex.core.query engine, which will allows us to convert the natural language into a SQL query. After that we are importing the OpenAI from the Llama Index. So we will going to use in this project the OpenAI model to convert that user query into a structure query language. So first we have initiated our create engine with the SQL example.db. So this engine we will going to pass into the SQL database. That engine plus include tables, means what are the tables we are having. So that connection we will going to establish with the help of create engine and SQL database. It will going to connect with the pre-existing database, which is over here example.db. that database we have a table name employees, so it will going to make a connection between that database. After that we are just connecting with this engine, and for just a testing purpose we are checking that select star from the employees. Based on that it will going to print the all the rows which is retrieved with the help of this query. So next, the main important part over here is that rather than writing this query, the user will going to ask like how many employees are there, show me the all the employees. User query will be converted into the this kind of structure query, and it will retrieve the data from the database. So how we are going to do, let's see. First we are creating a large language model with the help of OpenAI. Here we have passed the temperature is equal to 0.1 and the model name. Here you need to define your model, the subscription model, whatever model you have taken, those model name you can define. And after that we are having natural language SQL table query engine. In that one we are going to pass the connected database and the table name, which is employee, and the large language model. Now you just need to write a query like how many employees are there. This query will be fed in this query engine with the help of natural language SQL table query engine. That query will be converted into the structure query language, and that query structure query language will fetch out the data from the database, and it will show you into the terminal when you will run this project. So that was the way to build the application with the help of llama index. Next we will see the prompt engineering, what exactly the prompt engineering are and what are the techniques to implement the prompt engineering. What exactly the prompt engineering is? So it is practice of designing and refining prompts, specific inputs or query that you give to the large language model to guide it into producing the desired output. So first we'll see what exactly the prompt. So prompt is just a request to a generative AI to perform a specific task. It requires context and detailed information to produce accurate and relevant response. So that is the definition of prompt. So what are the key techniques in a prompt engineering? First one is a clear and specific prompt. Instead of asking tell me about neural network, or more specific prompt like explain the basic of neural network in simple terms suitable for a beginner. That helps the model to generate a more targetable or useful response. Next one, we are having a few shot learning. In few shot learning you provide the model with a few example of the desired input output pairs within the prompt itself. This helps the model to understand the context and format better. After that we are having a zero shot learning. In zero shot learning you ask the model to perform a task without providing any example. This is useful for simpler tasks or when you want the model to generate something based on the general knowledge, like translate the following English sentence to Spanish. Fourth one, we are having a chain of thought prompting. The chain of thought prompting help encourage the model to break down complex tasks into a sequence of a smaller step or a logical reasoning process. For example, explain how the photosynthesis works by describing each step of the process in the details. Next one is intrusive prompt, providing the simple model with a clear instruction within the prompt to guide the type of response. For example, like write a short story about a space adventure but keep it under 100 words. This is the example of intrusive prompt. After that we are having a contextual prompt, which is the last one, supplying the background information within the prompt to help the model to generate a more accurate response. For example purpose, like considering the recent advancement in AI, write a summary of how AI is impacting healthcare. So that was the example of contextual prompt. These all prompt techniques can be used in several applications like content creation, data analysis, customer support, or education and training purpose. So with the help of prompt engineering, those kind of application you can build it. Main important thing is to securing our LLM models. How to construct a security layer for a LLM application. So this is the example. We will be able to build 3 layers: layer 1, layer 2 and layer 3. Layer 1 is a keyword search, layer 2 is a semantic search, layer 3 is a semantic search while retrieving. So this one is a keyword search or this one is a semantic search. We also called it as a logical routing in case of advanced RAG techniques. So we have seen the RAG techniques. In the case of advanced RAG techniques, in the routing section we have a two options: logical routing and semantic routing. In simple terms, it allows us to, based on the query, which database to choose. When you have a multiple database, your logic will going to decide which database to choose based on the prompt. So the both logical and semantic routing we are using to secure the LLM. How? For example, you have written any particular logic. If you have built a particular application or an LLM based application, and the person is asking about like a racist, abusive or sexual words present in that prompt, so those kind of query, if that person is asking, so if those word is present in that user query, so you will just going to return that sorry, I can't answer of this question. Otherwise, means if those words are not present, you will return the answer based on your LLM context or retrieval. That happens in the case of logical routing. In logical routing means you are just going to write the particular logic, if else statement, and or you're matching any word is present in your query, then you should ignore that query. If it is not, then you will going to answer. In case of semantic routing, you will check the user query with the predefined prompt, that you will going to do the similarity search with the help of embedding model. After doing the embedding, you will going to do the similarity search. If it is matched, then you can return sorry, I can't answer the question. Otherwise, return the answer. So that was the way. During the query, you will do the keyword search. If particular keyword is mentioned in that query, then you will want going to return the response. If it is not, then you will pass to the layer 2. Over there it will going to do the semantic search with the predefined prompts. If it is matched, then you will going to return. Otherwise, you will going to retrieve the data or pass to the LLM model. LLM will going to generate the answer. Again, you are doing semantic search on the retrieved data. You will going to do the semantic search, that is anything is similar to the predefined prompt, then you won't going to answer. If it is not, then you will respond to the user. So that was the way to build a security layer for LLM application. Next topic is AI agent. What exactly the AI agent is? What are the tools which we can use to build a AI agent application? AI agent is also known as an intelligent agent. There are software entities that perceive their environment, make a decision and take action to achieve the specific goal. So main motive is to achieve that specific goal by making decision and taking the action automatically based on the environment. So what is the purpose of AI agent? AI agent can do a wide variety of tasks, which are like browsing web, write and execute code, book a meeting, make a payment, analyze and query data. So these are the tasks which can be performed by the AI agent. Let's understand it with the example. So imagine that no more endless scrolling through the web page for research. General problems is happen that you will go to the Google and multiple web search you have to do. You will read and find out the most important one, or you wanted to summarization of all the web page. So no more scrolling on the web page. That automation we can do with the help of AI agent. So how exactly it will happen? So you will going to write your query and it will going to search on the web page, and it will retrieve the 4 to 5 web pages data, and at last it will do the research on it, and it will going to provide the final summarized answer to the user. So that is the automation is possible with the help of AI agent. So what is a react? React means reasoning and action. So whenever you will ask a query, then you will going to thought on that query, and after that you are taking the decision. That we called as a react. That is the agent works. So agent perceive their environment, and according to that it will going to think and that take action to achieve specific goal. We can build AI agent with the help of Crew AI. Crew AI is a framework designed to create and manage teams of agents working together. Think it like a platform for building a well-oiled crew. But instead of human workers, you have AI agents with the different specialties. So in simple terms, Crew AI help us to build the teams of agents. So next one we are having a AutoGen. So AutoGen is an open source programming framework for building an AI agent. AutoGen is provided by the Microsoft. This one allows us to build a team of AI agents. and it can do several tasks. Like you can build a conversable agent. Conversable agent means each agent will going to talk with each other and takes action. For example, this is the supervisor you can assign. It will going to monitor of those 2-person tasks. Those all AI agent will communicate each other to achieve the specific goal. Same thing, you can do the multi-agent conversation as well as flexible conversation. So with the help of Crew AI or AutoGen, you can build a AI agent as much as you want. Let's see an example to understand this in a better way. So this is the project which I have built with the help of Crew AI. In this one, we are using a large language model from a Grok, which I have already shown you. The model which we are using over here is a Llama 3 model. So first let me explain the project, which is customer support ticket classification and action. In this project we will develop a system that automatically classify incoming customer support tickets into a relevant categories and take appropriate action based on the classification. The system should be able to distinguish between the urgent issues requiring immediate attention, routine inquiries, and non-spotted related messages. Upon classification, the system should take one of the following action. The first one is the urgent issue. Tickets classified as urgent should be triggered an immediate notification to the appropriate support personnel or department and escalate for an immediate resolution. Next one is a routine inquiry. Ticket classified as a routine inquiry should be assigned to the relevant support team for response within the standard response time. The last one is a non-sport related messages. Ticket classified as a non-sport related messages such as feedback, general inquiries or spam should be automatically filtered out and not responded to. So let me explain you the project. So first of all, you need to install the dependency which is written in this requirement.txt file. To install that, you just need to type in your terminal pip install -r requirement.txt. It will going to install the all dependency from the requirement.txt. In the app.py file, we are importing agent, task, crew and process from the Crew AI. Next, we are importing OS, which is operating system. After that, here we have defined our API base, model name and API key. The API base we are using from a Grok. The model which we are using is a Llama 3, and over here you just need to paste your API key from the Grok. After that, here I have just defined, this is just for example purpose, customer support ticket unable to access account. So that will be from the user side, and based on that AI agent should be take appropriate action. So based on that, first AI agent should be classify that which category it should be falling and it should take action accordingly. So here we are creating the two agents. First one is a ticket classifier and second one is a ticket action taker. So the agent are responsible for classifying customer support ticket and taking appropriate action based on the classification. Role we have given over here is a ticket classifier, and the goal is given here is accurately classify incoming customer support ticket into a relevant categories: urgent, routine or non-support related. After that, we have to give the backstory. You are an AI assistant tasked with classifying incoming customer support tickets to help streamline the support process. Here we have given the purpose is equal to true, allow delegation is equal to false. The next agent we are creating as a ticket action taker. Agent architecture is going to be same, but the role and the goal which we have defined, it should be different. The role of this one is a ticket classifier, this one and this one is ticket action taker. So accordingly we have given the goal and the backstory. After creating an agent, we will create a task. So as much agent you have created, that number of tasks you have to create. So here we have given the task which we have imported from the Crew AI. So description we have given, classify the following support ticket, and here we are passing the ticket which we have written over here. In that task we have to pass the agent also. So for this task we are using this agent, so that agent we will going to pass over here, and the expected output what should be, that one we have written over here. One of these three options: urgent, routine and non-supported related. So that is going to be output of this first task with the help of this classifier agent. The next task is going to be related to action. So here we have given the description, take appropriate action to the spot ticket based on the classified provided by the classifier agent. Here we have given the agent equal to agent taker, which we have defined over here. And expected output should be an action taken on the ticket based on the classification provided by the classifier agent. And here we are creating the crew AI, which allows us to combine the all AI agent. And here we have, with the help of crew AI, we are passing over here the both agent and the both task. We have passed over here the agents and the task. We have kept the verbose is equal to 2 and we are processing it as a sequentially. After that we just executing that crew by running the crew.kickoff and we are printing the output. So that was the way to build a AI agent with the help of crew AI. In case you wanted to build with the help of local LLM, so we have seen that we can use Olama to access the large language model locally. Everything will going to remain the same, only the large language model which we are taking from the Olama. So that was the way to build a AI agent with the help of crew AI. Next we will see that how exactly it process and how it will going to give the output by running that code into the terminal. I will going to show you the output directly. After running this module, which we can run by the python app.py file, you will going to see that how exactly it works. So first it started the ticket classifier agent and the task. Here it has entered into the crew AI agent executor chain. So based on that, you can see I now can give you the great answer. It started thinking. First it will going to do the classifier with the help of that agent and it has entered into the crew agent executor. After that it has finished that change and then based on that it has classified as a urgent. Next it will going to run the next AI agent, which is ticket action taker. So that it will going to take that output from the previous agent and accordingly it will take the action. So here it has taken the action. So action taken is a notify urgent issue to tier 1 support team lead by email or SMS. So that are the action taken by the ticket action taker AI agent. So status we are able to see that in progress. So we are successfully able to build this customer ticket classifier and action taker with the crew AI. In my upcoming video, I will going to build a end-to-end AI agent based application and I will going to share with you all that how to build such kind of end-to-end application. So in this Gen AI course you have learned the what exactly the Gen AI we have learned from the scratch. Please like and subscribe for more such videos and thanks for watching. Thank you.